Hi, my name is Liliane Silva. I'm a postdoctoral researcher fellow working for Drs. Mullenix and Gillard at Auburn University, and I'm here today to talk about our alfalfa and Bermuda grass study here in Headland at the Wiregrass Research Station. So, we established this study last year, and this is our first year of data collection. Here we have 6 paddocks. Each one of them is 1.8 acres, and this is only rain-fed. We don't irrigate this area. So the preparation of this area started last September when the existing Bermuda grass field was cut for hay. Here we have a mix of Chieftain 85 and Russell Bermuda, and after it was cut for hay, we turned animals in to clean up and to get to a 2 to 3 inch stubble high before we plant alfalfa. So in late October we planted alfalfa using a no-till drill and a seeding rate of 15 pounds per acre with a row spacing of 14 inches. Here we are using Bulldog 805 variety, and there are a lot of other varieties that people could choose from to use in South US, but and including varieties that have Roundup Ready genes, which facilitates the weed control weed management of broadleaf weeds. But so on this case, Bulldog is not one of those, and we are more limited on the options that we have to control broadleaf weeds here. At planting, a light rate of Roundup was used as recommended to suppress the grass and control emergent weeds. Initial soil testing was done before we planted alfalfa, just to make sure we applied the lime needed and also to get the recommendations for potassium and phosphorus for the area. So when you are planting alfalfa, soil sampling needs to be conducted for the surface, which is 0 to 6 inches depth, and for the subsurface, which is around 6 to 12 inches depth. And this extra sampling is crucial when you are planting alfalfa because its roots go deep on the soil profile, and it requires pH to be at least 5.5 on that depth to be able to use the nutrients that are there and to establish well your stand. So for alfalfa, it's also important to apply boron and molybdenum at planting because those guarantee proper conditions for nitrogen fixation. Alfalfa is a legume, so it fixes nitrogen in structures that are located on its roots. They are called nodules. So those structures are as factors that produce nitrogen, and one of the supplies are those nutrients that we just talked, boron and molybdenum. So that's the reason we need to make sure that they are getting as much as they need. And after alfalfa grew here, the paddocks have been scouted weekly for insects, and when necessary, we applied Mustang Max to control insects. And so far, we applied in March before we started the data collection here because we had some alfalfa weevils. And the latest, the other application was in late July, and we only applied on hay paddocks because we needed to control Bermuda sting maggots. And the reason we only applied on the hay paddocks is because we have animals grazing, as you can see here on the back, on the grazing paddocks. And we were worried that the pesticide could drift and come to the forage that the animals were about to eat, and that would get them sick, so that's not ideal. That's the reason we only applied on the hay paddocks. For the fertilization management here, we are applying 200 pounds of potassium per acre per year, split in 3 applications. And because alfalfa is a legume, as I just mentioned. We don't need to apply nitrogen. So all the nitrogen that the Bermuda grass is getting is from alfalfa fixing nitrogen on this system. To make sure that we are having all the nutrients that both plants need to, we collect plant samples. So around mid-July, which is kind of the mid-season, we came here and just randomly walked through the paddocks and collect samples, just grabbing plants around, and took that fresh sample to the lab in Auburn to have it analyzed and see what were the deficiencies that the plants were facing and what we needed to apply as fertilizer. And for our system, we only needed to apply potassium, so we did. And we will do a more thorough nutrient management on the beginning of the next year, and make sure that we're applying more boron and just make sure that we apply everything that the plants need at that point. So on this area, we have 3 different managements being used. One is cutting for hay or baleage, another is grazing, and a third one is a dual purpose management, which means that we cut or graze those paddocks depending on the time of the year. For paddocks that we cut for hay, we follow the recommendations of cutting every 28 to 35 days to 4 inches stubble height, and we have been baling that material for baleage. So the way that we do, we cut the material, the paddocks in the afternoon, and we bale on the next morning when the material is around 40 to 60% moisture. Then on paddocks that we have animals grazing, we are using rotational grazing, and so we split these paddocks in 4 strips. As you can see, we are using fencing, temporary fencing here. So they were just to make sure that we had those little strips inside each paddock, and we rotate animals every 7 days for the following strip. So on this study, we are evaluating forage yield, quality, and animal performance. And this is the first year of this system, and just in general, we are expected to have best production and a greater percentage of alfalfa on the first 2 years of these systems. So this is a major point of be looking at how alfalfa will persist over time on your system, and one of the ways to guarantee that is to make sure that you are doing a proper cutting or grazing management on your system. And one of the main points to do this is that the first cut or before you turn animals in ever, like after you plant alfalfa, is to allow the plants to get to a point that they are around 20 to 25% blooming in the area before you cut or you turn the animals in, just so the plants can grow and establish and accumulate reserves that they will use to regrow after you remove the forage there. Another point is to make sure that you're leaving enough residual leaf area on your stand, on your field, to make sure that the plants continue to be able to grow after that. So here on this area, we had around 50% for alfalfa and Bermuda before we start the study this year, and for all treatments. And as we expected, we saw a decline of alfalfa and an increase of Bermuda grass as the summer went by. So this was expected, as I said, just because the Bermuda grass peak of production is around midsummer. So we will show around a little bit later, and we have more Bermuda grass growing on most paddocks right now. And we have not yet analyzed our forage samples for nutritive value, but we are collecting samples before we cut, or we turn animals to a new strip every week. And in the baleage that we're storing after 8 weeks that they were sitting there, just when the fermentation is expected to be stabilized on those bales. Then, just to have an estimate of forage yield here, on average, we are getting around 6,500 pounds of forage per hay cut. And on our grazed paddocks, our stocking rate has been around 8 to 16 animals per acre. And on average, since the animals were turned in the paddocks, they have been gaining around 1.5 pounds per day. So this is what I had here, and I'll just show some extra information later.